The electrochemistry, and we are discussing about different type of conductivities. Okay, and in this section we have discussed till now the factors affecting conductivities. Okay, Khushi, can you say the name of factors we have discussed?
So, concentration or dilution, nature of electrolyte, and temperature.
Okay, so till now we have discussed about the nature of electrolyte.
Yes, sir, we've done it.
Okay, and second factor we have discussed, that is concentration or dilution. The factor number 3 we have discussed, that is temperature. Okay, so in this section now we have to take the next point, that is the effect of concentration or dilution on the conductivity of electrolyte. Okay, and here we are having an equation that is known as Debye-Huckel equation. So next topic is Debye-Huckel equation. So today we will discuss about this equation, and what are the here we are taking the points we are discussing here. Okay, so first of all we are writing what about this equation. It is about actually the effect of concentration on conductivity. Effect of concentration on conductivity. We can say molar conductivity or equivalent conductivity, all that we can take. Okay, so this is about this equation. Now we are writing this equation. This equation is known as Debye-Huckel equation, and one more name we are using for this, that is Debye-Huckel-Onsager equation also. Okay, and this equation is valid accurately for strong electrolyte and approximately for all electrolytes. So here first of all we are writing the name of these symbols we are using. This is known as molar conductivity at given concentration, that is C, at concentration C mole per liter. Okay, and lambda naught, either we can use lambda infinite also at place of this lambda naught. So we can use this lambda naught or lambda 0 also. If you are using this, then we are saying this as limiting molar conductivity, or we can say molar conductivity at zero concentration, or we can say negligible concentration or infinite dilution. So name is limiting molar conductivity or molar conductivity at infinite dilution, or we can say negligible concentration. So this is the name for lambda infinity or lambda naught. And now the C is known as molar concentration of electrolyte, or we can say molarity of electrolyte in the unit mole per liter. And then we are having a constant that is known as A, and this is constant for a given solvent and at given temperature its value depends on type of electrolyte. Type of electrolyte. So this is all about this equation. Okay. So now we are discussing again. This equation is as lambda c equals to lambda naught or lambda infinity minus a root c, and here this is molar conductivity at given concentration, this is limiting molar conductivity, and this is constant, and this is molarity of electrolyte. This equation is accurately uh, calculating the lambda naught or lambda c for strong electrolyte, and by using this equation we can calculate the approximate limiting molar conductivity for weak electrolyte also, but not exact value. So why it is not, we are discussing here. So you are to remember here the names of symbols, and one more thing, that is about A, that is constant we are taking here. And now here we are taking the type of electrolyte. Type of electrolyte means we are taking here like 1 type electrolyte, 2 type electrolyte, and all the type of electrolyte we are taking count here. If we are having two electrolyte and both are 1 type, and for similar solvent and given temperature, the value of A will be similar. Okay. For example, if you are having some electrolyte like NaCl, Ki, LiCl, MgCl2, strontium iodide, can you say, if we are considering the value of A for a given solvent and given temperature, then out of these all, which of the electrolytes are having equal value of A? Can you say, Khushi?
NaCl, Ki, LiCl will have the
Okay,
same type 1 type.
exactly.
And
NaCl, Ki,
MgCl2 and strontium
LiCl
iodide
will
will
have the
have
same type
2
1
type.
type,
Exactly.
and
So first we write
MgCl2
here
and
the
strontium
type of
iodide will
electrolyte,
have
that is
2 1
one
type.
type. One type means this cation is monovalent and anion is monovalent. So we are saying this electrolyte as one type. And again Ki is also one type. LiCl is also one type. And now what about MgCl2? Is it one type or not?
2 1 type.
It is one type. Here cation is
It will be a 2
bivalent.
1 type.
2
Right.
1 type.
Here cation is bivalent, so we are
It will be
writing
a 2
2,
1
and
type.
anion is monovalent, so we are writing 1. So it is 1 type. And what about SRI2? It is also 1 type.
It is
So
also 2 1 type.
now here we can say for NaCl,
It is also
for
2 1 type.
Ki, for LiCl, for all three electrolyte, the value of A will be similar. And similarly for MgCl2 and for SRI2, the value of A will be same. You got it? Here type of electrolyte means, the type of electrolyte means valency of electrolyte we are taking into count. Okay. And but condition is what? Here temperature should be equal and solvent should be similar. If we are taking different solvent and different temperature, then this is also depend on temperature and type of solvent. Okay, do remember. Now we are having plot between lambda c versus root of c, and we are explaining the effects of concentration here. So if we draw a plot between molar conductivity at concentration given c mole per liter and root of c, that is root of molarity. So can you say which kind of curve we are getting? We are having relation lambda c equals to lambda naught minus a root c. So this is kind of, we can say y equals to c minus mx type curve. Here at place of y we are taking this lambda c, at place of x we are taking root c. Can you say which kind of plot we are having between these two?
So it will be rising type.
Like it will be straight line or curved
So
line?
it will be rising type.
When we
So
draw
for
a
weak
curve line.
electrolytes, it will be a curved line, and for strong electrolytes, it will be a straight
So for
line.
weak electrolytes,
Exactly,
it will
this
be a
is
curved line,
accurately
and for strong
actually
electrolytes,
for
it
a
will be
strong electrolyte
a
only,
straight
and it
line.
is approximately gives the value for weak electrolyte. Okay, so for strong electrolyte it is totally, we can say, satisfied, and we can apply. So for strong electrolyte we are getting a straight line of negative slope. Okay, so for strong electrolyte we are getting this kind of line, like if it is start from here, then this kind of line. And can you say the slope of this line? Here the slope will be minus m. At place of minus m we are having what? Minus a. So slope of this curve will be minus a. And what about this limiting value of lambda
minus
c?
A.
This will be equals to lambda naught, limiting molar conductivity. Okay, lambda naught m we can use, or we can say this. Okay, so this is known as
Lambda
limiting
naught M.
value of lambda c, that is known as molar conductivity at infinite dilution or zero concentration. And for weak electrolyte we are getting a different curve, like this kind of line we are getting. This is curve for weak electrolyte. So we can say this curve is for like NaCl, it is a strong electrolyte, so we are getting a straight line. And this curve which is not a straight line, it is for weak electrolyte like acetic acid. So we are getting the different. And now we can say for weak electrolyte what kind of curve we are getting. We are getting this kind of curve actually. So it is not intersecting the y-axis. So if we plot this curve in this way and we draw this extra line toward back side, then we are getting this approximate value of lambda naught for weak electrolyte. So we cannot calculate exact value of lambda naught for weak electrolyte by using this equation. So it is not satisfied the accurate value of limiting molar conductivity for weak electrolyte, but for strong electrolyte it can give accurate value. And for weak electrolyte, to calculate the accurate value of lambda naught, we are using a different law that is known as Kohlrausch law. Okay, so it is all about Debye-Huckel equation, and if you are having any doubt you can ask. Andrilla, you got it? If you have any question you can ask, but I think if you are not go through before this previous section, then you
Yes,
have no
sir.
idea about it. If you know that, then you can get it easily. So now we are taking the next point, that is Kohlrausch law. Simply we can say Kohlrausch law, but its full name is Kohlrausch law of independent migration of ions. Okay, so now we are discussing about this law. What about independent migration of ion? We are taking example. If you know Ostwald dilution law, according to which we can say if we increase the dilution or if we decrease the concentration of an electrolyte by adding solvent, then what happen? The degree of dissociation of weak electrolyte will increase. Like if you are having any solution of weak electrolyte like acetic acid aqueous solution, we are taking in this vessel, and if it is 1 liter solution, so what is happening, it will ionize partially, and there are existence of both form, like one form this is known as non-ionized form and another form is ionized form, that is acetate ion and H plus ion. Okay, so now what happen if we add pure water to this solution? This we are explaining by using Ostwald dilution law. According to this, what is happening, if we add the pure solvent to any solution, there will be decrease of concentration. This process is known as dilution. As we dilute the solution, what happen? The degree of dissociation of weak electrolyte will increase. Means amount of ionized part will increase. Amount of non-ionized part will decrease. So this law is known as Ostwald dilution law. And if we increase the solution volume up to very large amount, then that stage is known as infinite dilution. Like if 1 liter solution we are taking initially and we mix suppose 1000 liter of water to this solution, then this kind of stage is known as infinite dilution. And at this stage the concentration of solution become negligible. Like if we calculate molarity, If initially molarity is 1 mole per liter for this, then after infinite dilution this molarity become negligible. It not equals to 0, but it goes to approx 0. So you got it? What the meaning of infinite dilution? Hello, Khushi, are you getting my voice? Hello.
Yes, sir.
Okay. So infinite dilution means what we can say, the concentration or we can say molarity is very less or it
Yes,
is
sir.
negligible,
Yes,
and
sir.
volume of solution is very high. Then we are saying it
Hello?
as, yes.
Yes,
Are
sir.
you getting this point?
Hello?
Infinite dilution mean. So here
Yes, I got it.
the stage where we are getting the molarity like point zero 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 zero
Yes,
like
I
some
got it.
digit here. So we can say it is negligible. This is known as infinite dilution. Got it? Now we are taking the meaning of independent migration of ion. Now see, suppose we are having a vessel in which we are taking this solution and the volume of solution is 1 liter, suppose up to this level, and we are having suppose 10 ions inside this solution. Okay, suppose this is one ion, this is two, three, four, like this. We are taking 10 ions. So here we can compare the distance between two ions will be this one if it is x centimeter. Now see, if we increase the solution volume by taking pure solvent into this solution up to this level, and suppose this is up to 100 liter. Now number of ions are 10 still, but the volume of solution becomes this one. Can you say what about the distance between these ions? Before dilution the distance was like this x centimeter. Now if we increase the volume of this solution from 1 liter to 100 liter by adding pure solvent, and the number of ions of solute are still 10, then what about the distance between these ions? Like this distance was before x centimeter. Now is it x centimeter more or less?
More than X centimeter.
More than x centimeter. Like now ions can present at higher distance like this.
More than X centimeter.
Okay, and electrolytes are having two types of ion, like positive and negative ions. And can you say if distance between these ions will increase, then what happen on electrostatic force of attraction?
So that will decrease.
Simply we can say attraction force. The attraction force will decrease. If attraction force will decrease,
So that will
like this ion is moving
decrease.
randomly, and attraction of this positive ion on this negative ion becomes negligible, then what happen? This ion can move freely or not? If
Yes, sir.
attraction force due to cation on this ion, this becomes zero, suppose, then what about the moment of
Yes,
this
sir.
negative ion? This can move freely or it is still in bounded motion?
It can move freely.
Freely. So this kind of motion is possible when the distance between these ions is very large,
It can move
and
freely.
the effect of force of any ion on other ion will be negligible. And this, in this situation the ions are moving. That kind of ion is known as independent migration of ions. So we are using a term here like independent migration. Independent migration means the movement of any ion is not affected by the presence of other ion in the solution. You got it? And this is happen
Yes, sir.
only when the volume of solution is very large, or we can say the stage as infinite dilution. At this stage it can be
Yes, sir.
possible. If volume of solution is very small, then this independent migration of ion is not possible. Okay, because the distance between ion is limited, then force of attraction will be significant, or we can say effective. So one ion cannot move independently because other ion affect the motion of that ion. Okay, so now you got the meaning of independent migration and infinite dilution. Now we are taking The next thing is, if we increase the dilution, if we increase the volume, then degree of dissociation will increase. So we are taking example, like if you are taking acetic acid and at concentration equals to suppose 0.1 molar, the degree of dissociation of acetic acid is, suppose it is 10%. We are taking example like 10%. If the concentration or molarity becomes 0.00001 molar, then what about alpha? It is more than 10% or less than 10% or it remain 10%, and we are taking the temperature as constant 25 degrees centigrade suppose. Can you say what about the alpha? Alpha here is known as degree of dissociation, means fraction of this acid will be which will ionize is known as alpha. What we are doing initially, we are taking this concentration, alpha is 10%.